to you. I'll just let you leave. Yo, what's up, guys? It is another beautiful day, and it's day 5 of studying math every day. I think I'm consistent. I did it 5 days consecutively. So yeah, today is it's Friday. It's a weekend where I live in. So to be honest, on the weekends, I don't do nothing. I always like to stay away from my computer, like stay away from keyboard, basically AFK. That's what I like to do the most. But to keep this streak, I have to study at least one session. So I'm about to start my first session, and I won't study new topics, but instead I will just go back to the lessons that I have learned already. So I'm gonna review them. So how I will retain some information, what I will do is just like I will just take a look at the title of the lesson maybe, and then I will try to like retain some information from that lesson. And if I cannot, I'm just gonna go back and read it. That's the system that I will use. So yeah. So let's go and let's start. Is that in? I think I'm getting comfortable with the camera. I don't know. Oh yeah. For somehow I cannot study without music. Without this music, I cannot study. I got a bunch of music in here, so this is I prefer this one.
Random answer as negative.
Uh,
X plus.
I struggled with this problem yesterday. I'm not gonna do it again, but I'm gonna do it again. Maybe tomorrow. I don't know. So yeah. So yeah. Now I'm about to go back to the old lessons, and I'm gonna get my notebooks too. So I'll just go in a mute, and I'll just study. So I also wanna take a look at like a factoring method, which is called AC method. AC method. So I was seeing this like somewhere. I don't remember the day, but like it was maybe day 3. I don't know, but like I think AI mentioned it or a teacher just mentioned it. I don't know, but I wanna look up the AC method that is used for factoring a polynomial. AC method. I just kinda wanna know. Yeah, maybe
In
this
we're gonna
video.
focus on factoring trinomials with a leading coefficient that is not 1. So here's an example. Let's say if you have this expression, 2x squared minus 5.
I don't need to. I already know these parts. I know how to use it by grouping. But all I need is just like the AC method.
X minus 3. How would you factor this expression? So what you want to do is you want to multiply the leading coefficient, 2, and the constant term. 2 times negative 3 is equal to negative 6. Now you want to find two numbers that multiply to negative 6.
It is 3, negative 3, and positive 2.
But that add to the middle term, negative
Like
5.
the same.
So if we multiply 2 and negative 3, that doesn't add to negative 5, that adds to negative 1.
Okay. So they should add to negative 5. Multiply to like 2 and like A and C multiply to minus 6. So we need two numbers. Just give us like minus 6 when multiply, and also minus 5 when add.
But if we
Is that how it
multiply
is?
6 and negative 1, that adds to positive 5. But if we change the sign, negative 6
it makes
plus
sense.
1 is negative 5, and negative 6 times 1 still multiplies to negative 6. So these are the numbers that we want. Now once you find those two numbers, what you want to do is you want to replace the middle term, the negative 5x, with negative 6x plus 1x. As you can see, the value of the expression remains the same. Negative 6x plus 1x is equivalent to negative 5x. Now at this point we can factor by grouping. That is, you want to factor the GCF from the first two terms separately from the
Just
last
be
two terms.
2. It will be 2, so there will be AC will be 2x. The first group, and the second group it will just be. Yes. Will it be 1? Yeah, it will just be 1.
And you can tell when you can factor by grouping. Notice that the ratio of the coefficients of the first two terms is the same ratio as the last two terms. For example, negative 6 divided by 2 is negative 3. Negative 3 divided by 1 is negative 3. Once you see that, if you see that same ratio, then you know you can factor by grouping. What is the GCF, or the greatest common factor, in the first two terms? That is between 2x squared and negative 6x. What is the
Split B2,
greatest factor that we can
2x.
remove? The greatest common factor is 2x. 2x squared divided by 2x is x. Negative 6x divided by 2x
Minus
is
3.
negative 3. Now, in the last two terms, there's no greatest common factor that we can take out. So whenever you see that, just take out a 1. 1x divided by 1 is x. Negative 3 divided by 1 is negative 3. So notice that we have a common factor, x minus 3. If we factor out x minus 3 from the first term,
Yeah, just leave it as it is. So basically, the AC method is first you're gonna multiply the A coefficient A to the constant, and then you're gonna look for, you will get a product, right? And then you're gonna look for two numbers, those multiply to that number, basically at this moment 6, and then add to the B coefficient, which is like 5 minus 5, or maybe negative 5 at this point. So yeah, I understand it now. Understood. Got it. Got it.
all we have left over is 2x. If we take it out from this,
This dude is a savior, man. Yes. This thing is just like, oh sorry. This person nailed it on the head. That's why math is one of the hardest subjects, but it is fun when you know the ideas and the techniques of solving it. So math is just like, it's just like a puzzle, you know. You're gonna learn one puzzle and you're gonna know another puzzle another time, and it's just like one time they will give you a problem, and that problem contains a bunch of puzzles, and you're gonna combine all of these puzzles, like I mean ideas and techniques at this point. Okay, you're gonna bring all of these techniques and you're gonna just like bring them together, and that's how you can solve a puzzle. So math's just like that. You cannot solve a problem without not like when you don't know, basically you cannot solve a problem without knowing something just like distributive property, or maybe how to deal with radicals, or maybe how to like make balancing, just like if you add something to the right side of the equation, you should also add the left side of the equation. If you don't know this techniques, then that means you won't be able to solve it. So it's just like a bunch of techniques and ideas combined together. And this is what I was missing when I was young, man. This is what I was missing. I used to try to solve some hard problems in high school when I didn't even know the basic maths. The only way I used to solve a problem was just like following the steps that's followed by the teacher that was teaching me at that point. I couldn't solve it on my own, and without formula, that was like a disaster. I couldn't even approach the problem. So yeah, math's just like so damn good, to be honest. And yeah, I agree with her. She's a girl, I think. So yeah, all of these people talking about how they understand, but I cannot, dude. It happens. So yeah, this guy explained how this works in 3 minutes. I wish I found this earlier, but yes, I already understood this like in a second. So damn good. So yeah, I got 5 minutes left, and yeah, I think I'm free to go. So yeah.
In this video, we're going to focus on factoring.
Okay, so we got a special case now. When we first introduced them on it, because they... Okay, so we got a special case now. When we first introduced linear equations, we talked about the three cases that you have. Now, almost all the time, you have these linear equations ending with exactly one solution, the one number that makes this equation true. But there are two other cases. Cases when we have no solution, and cases where we have infinite solutions. We're going to look at those two cases today. We're spending a little bit of time on it because they look very similar if you're not really paying attention. And no matter what, they look really weird. So you're going to do them and go like, what the heck? What's going on here? And a lot of times students get stuck because they don't know how to interpret what's going on. So that's what we're going to do. These are the only three examples that we're going to take a look at today. The first one, very special one, I want to talk a little bit about that just to get out of the way, and then we'll focus more on these ones. Firstly, when you have like something like 8x equals 0, this definitely linear equation, hey, one variable to the first power, definitely linear. A lot of students will look at that and go, that's not possible. You can't have 8x equals 0. I mean, what would you plug in to multiply by 8 to get 0? Well, what would you do? What would you multiply by 8 to get 0? Well, 0. This is not a case where you have no solution. This does have a solution, but a lot of students get tricked and they go, well, you can't do anything with this. Sure you can, follow your steps. Can you simplify it? Well, no. There's no distribution, there's no like terms, there's no fractions, no decimals, there's no smaller variables, so steps 2's out of the picture. There's no constant next to the variable. This is your coefficient, nothing added or subtracted, so there's no constant. So basically, we're on the very last step. We're on the, hey, just divide. Get rid of your coefficient. So if we have our 8x equals 0, how do you get rid of the 8? Well, 8's connected to your variable by multiplication. Let's undo that. Remember, with division, we're trying to get ones next to our variable. 8 divided by 8 is 1. 1 times our variable gives us back x. On the right-hand side, that looks a little funky. Go, what the heck? Can I divide 0 by 8? Well, sure. Can you divide 8 by 0? Well, no, but that can't happen in linear equations. If you end up dividing by 0, then you don't have a variable to start with. So you can't ever divide by 0 in linear equations. It's not legal mathematically, you can't do it. But you can divide 0 by a number. I'll prove it to you. Can you take a pizza that has 8 slices? That's what fractions mean. Your denominator tells you how many pieces you've cut something into. Here's a pizza with 8 slices. Can you have a pizza with 8 slices and have 0 slices? Sure you can. It's called a diet. So can you see the pizza and not have any? How much pizza have you had? 0. That's what this represents. It's a pizza with 8 slices. You have had none of them, hence you've eaten 0 pizza. Okay? Now, the other one, just to be thorough. This means this. This means take no pizza. It doesn't exist. Now eat 8 slices. It's tasty. Can you do that? That's impossible. You can't have 8 slices out of nothing. That doesn't make sense. Unless you're my little 3-year-old daughter, she imagines this all the time, that's great for her. But that pizza doesn't taste very good because it's imaginary pizza. This is impossible. This is certainly possible, hence there is a solution, the solution is 0. Dividing a number by 0 will not happen in linear equations, therefore this you don't have to worry about. Okay, now the other stuff. Let's go through it. We're not going to spend a whole lot of time doing the math on this. This is not what this lesson is for. This lesson is to interpret the results. So you at this point should be really good at determining linear equation. That looks really funky. I messed up on something here. That can't have that. There we go. So interpreting, yes, linear equation, we've got one variable raised to the first power, there's an equal sign, and another linear equation, one variable raised to the first power, equal sign. So let's go through our steps kind of light speed. If you want to pause the video and try on your own, do it. But we should be noticing the first thing I'd be doing is simplifying. We'd be distributing. We'd be making sure we hit our -2 distributing. We'd be combining some like term. Oh, and here's where it gets weird. When you start combining like terms, and after you combine your like terms, all of your variables disappear. And you go, what the, 4x minus 4x is 0. Yeah, that's okay, that's fine. 0 x's, your x's are gone. It starts to look a little weird. Keep going, don't stop. Combine your like terms with your constants. You have +2. Hang on to this for a second. I'm going to interpret this in a little bit. Do the other one. So we check out my linear equation. We know that we've got to distribute first. No problem. Leave your 2x. Get your minus x minus 5 by distribution. On the right-hand side, we get x minus 5. Let's combine some like terms. None here. No like terms on this side. Yes, like terms here. We get a 2x and a minus x. That gives us x. And you go, oh, dude, that's weird too. If ever you get the same exact thing on both sides of your equation, something's a little fishy here. Get rid of your smaller variable. You go, I don't have a smaller variable. Okay, let's just subtract x for funsies. You subtract x and you get -5 equals -5. These are the two cases where you have either no solution or you have infinite solutions, and it's all about the interpretation. You can see from the board they look very, very similar. In both cases, you completely eliminate the variable. That is not what's telling you no solution or infinite solutions. Completely destroying the variable, whether you combine like terms and getting no variable, or whether you're adding or subtracting on both sides and getting no variables left, that's not the key. The key is what you have after that. So look down at your answers, I suppose. Look down here. The key is determining if this is never true or if this is always true. So when you're looking at the difference between no solutions and infinite solutions, both cases, you're going to be eliminating your variable entirely. Now look at what you have remaining. Is 2 ever equal to 10? Ever? Well, no, because if it was, I'd say, hey, you bring $10 and I'll bring $2 and let's swap because it's equal. That doesn't make any sense. So if this is not equal, this is no solution. This is never, ever, ever true. This side never, ever equals this side. It can't happen. You've eliminated your variable. There's no way to make it possible. This, when you've eliminated your variable completely and your two sides are not equal, you have no solution. Please make a mental note here. If you don't get rid of your variable completely, you have a solution, no matter what it looks like, okay? So if you have a variable still in a linear equation, it's got a solution. Only when you completely eliminate the variable through your math, through your simplification, or through your getting rid of a variable on both sides, that is when you have these two cases, no solution or infinite solutions. That's why they're rare. So when we get down with no variable and our sides are not equal, they're never equal, that's no solution. When we eliminate our variable and we get down to here and we have sides that are always equal, -5 is always equal to -5. You can show this too. Even if you added 5 to both sides, you get 0 equals 0. 0 is always equal to 0. No matter what you do here, the two sides are always equal. In fact, you can stop right here. X minus 5 is always equal to x minus 5, no matter what you plug in, because you'd have to plug it in here, and you'd have to plug it in here. Take 50, take a million, take negative 37. It's always going to be equal. This is the case where you have infinite solutions, because no matter what you plug in, you're going to make a true statement. So the difference is not whether or not you eliminate the variable. If you eliminate the variable in a linear equation, you're going to be one of these two cases. Look at what's happening in the cases. Are you never true, so your sides don't equal? No solution. Are you always true? Your sides are always equal. That's infinite solutions. That's the difference. It gets tricky because they look very